part A anyway isn't too nasty. I know because I've just done it all, but then realised that my microphone was turned off. Really frustrating this. But let's actually do part A. It's not this bad, part A. It really isn't. I just thought for 6 marks it must be quite tricky, but then I realised it's because they want you to find the x and the y coordinates. So we've got EA to minus 3x minus 3e to the minus x. I'm sure you'll all agree to find a turning point, you need to differentiate. Minus 3e to the a minus 3x, because remember, a is a constant, so it differentiates to 0, plus 3e to the minus x, and then we're going to set that equal to 0. Make sure you write that down in the exam as well, because they need to see that you understand the gradient is 0 at a turning point. Then we can write this, a minus 3x equals 3 e to the minus x. Divide both sides by 3, obviously. You're going to get e to the a minus 3x equals e to the minus x. You could take natural logarithms of both sides then, so a minus 3x is minus x. You're then going to subsequently get a is 2x, and so x is a over 2. Remember, we're trying to find x there. And now you can find y by plugging that back in. Now, a minus 3a over 2 is actually minus 0.5a. And then you're going to have exactly the same thing over here, minus 3e to the minus 0.5a. And so the answer is minus 2e to the minus 0.5a. And it's always nice to write those down actually as coordinate pairs. So what have we got? We've got a over 2. And this is what p equals, by the way, minus 2e to the minus a over 2, I believe. And that is part A. For part B, all we need to do is, let's have a look, find q. Now, q is where y is 0. So you've got 0 equals e to the a minus 3x minus 3e to the minus x. Okay, let's use a similar approach to last time. Let's have 3e to the minus x equals e to the a minus 3x. You can see a couple of ways of thinking about this now. Maybe you like this way best. You could take natural logs of both sides and do it with natural logs, but I feel like this is going to be slightly easier. Leave that alone, but write this as e to the a divided by e to the 3x, because the way we'd handle that is by subtracting the powers, and so it is in fact equivalent to the line above. We can now times the e to the 3x over, giving us 3e to the, add the powers, 2x equals e to the a. And now, well, I suppose we've tied it up. Now, really, to undo that, we're going to have to take natural logs of both sides. So we're going to get natural log of 3e to the 2x equals natural log of e to the a. Now, I agree the right-hand side is just a. I'm just leaving it like this for the moment. The left-hand side I want to write as ln 3 plus ln e to the 2x equals ln e to the a. Now let's get rid of as many pesky logs as we can. This is just 2x, this is just a, but this is ln 3 still. And so what you're going to get is x equals a minus ln 3 all divided by 2. Hope that makes sense. Okay, what are we looking at for part C? Let's have a look. Let's scroll down a little bit. Sketch a curve. Oh, and it's a modulus of the whole curve. Now, let's get rid of that writing for a moment. If you've ever got this kind of situation in maths, if you've ever got y equals mod of f of x, well, that's a bouncer. This is the way I do this topic. It actually will not make any sense to you actually thinking about what I'm about to say, because I didn't teach you this bit. I think you did it with Miss Grant, and I very much doubt she uses the same phrases. I call these ones bouncers, and I call these ones faces, and that's because these ones bounce off the x-axis. And it's because y can't be negative for those ones. For the second type, y can be negative actually, because you're taking the modulus of the function. And with those ones, they have reflective symmetry in y-axis. And so just like your face in y-axis, it will, I call them faces. But anyway, this one's a bouncer. So in other words, y cannot be negative. So when we see what we've got here, which is this curve here, we're going to bounce it off of Q and let it tend towards C. So on my sketch, it's going to look something like this. Let's draw. Sorry about I'm not great on the tablet, but it seems to me it's going to be going boing and then tapering off there. It's going to have the same coordinates here. It says show in your sketch the exact coordinates in terms of A of the point at which the curve meets or cuts the coordinate axes. So we better go back up and have a quick look at this diagram again. Okay, look at that. Oh, it's just so perfect, that diagram, isn't it? We need to therefore put where it crosses the y-axis and the x-axis. I don't think it's asking for P, is it? No, it's just asking for the it's just asking for the intercepts. So how are we going to find those? Well, I suppose I ought to label my axes, even though it's a terrible diagram. Blimey, that should be going down like that. It shouldn't be going up like that. It should be heading towards the x-axis. But yeah, okay, so for finding the y-axis intercept, just let x equal 0. And if we let x equal 0 in that equation, you're going to get e to the a minus 3, and that's it. E to the a minus 3. That's that coordinate there. Let's put it in brackets so that's nice and clear. And this one, well, I think we just worked out this one, didn't we? It is a minus ln 3 over 2. And I think we've got everything there that we need. So that is it. So without further ado, let us move on to the next question. Okay, what have we